Good afternoon, Sydney. I'm super excited to be here. Looking around at everyone, wearing your headphones, it actually makes me feel like a DJ. So I'm going to do something which I always wanted to do. So if you can hear me, give me a rock on. Woo, awesome. Welcome here. So looking around, the first thing that goes through my head is how many people are actually in this room? Let's face it, as humans, we love numbers. We love statistics. It helps us make sense of the universe around us. This is true, especially in sports. Numbers and statistics help us put into perspective the magnitude of effort and skills exhibited by athletes on the world stage. Let's have a look at the America's Cup boats, for example. Did you know that one of these boats maxed out at 53.4 knots? That's 99 kilometers per hour, and that's powered by wind. Simply amazing. Next up, let's have a look at something closer to home. Did you know that the Australian men's cricket team has the record for the most consecutive wins in Test cricket at 16? 16 wins on the trot. Simply amazing. Also under the feet is by Australian pace bowler Mitchell Starc. Did you know that he's bowled a delivery at 160.4 kilometers per hour? That is quick. If you have ever played cricket, try measuring your bowling speed. When I was younger, I used to call myself a pace bowler. And I can guarantee you that my fastest delivery was most probably slower than the spinners at the world stage. It puts things into perspective. So why am I telling you all this? All these numbers and statistics are powered by real-time data, processed at speeds, and delivered to commentators, broadcasters, and most importantly, to us, the spectators, so we can have those moments of ooh and ah. So welcome to the talk today, where we'll be looking at practical tips on how Virtual Eye delivered a real-time processing engine for sports on AWS. I'm Ruskin Dantra, a solutions architect from New Zealand, and with me today is John Rendell, Head of Innovation and Technology at Virtual Eye. In today's talk, we'll be looking at various theoretical aspects and how Virtual Eye used them to deliver a real-time architecture. We'll be looking at the intersection of three core architectural patterns: request response, event-driven, and streaming architectures. We're not going to be diving deep into any of these in particular, but leverage some established principles which helped Virtual Eye deliver deep insights for sports. Let's quickly look at the agenda for the next 30 minutes. We touched on the why a little bit. The why is very important, and we often underestimate this. We might all know the why, but articulating it from a value proposition is very important to ensure success of a real-time architecture at a company-wide level. Next up, we'll look at some theoretical journeys to real-time architecture, followed by how we help Virtual Eye apply them to create a real-time processing engine for sporting data. I'll then pass it on to John, who will take you through their journey, some of the obstacles they faced, the mitigations they applied, and the result, wrapping up with some key takeaways, which you can then apply to your real-time journey. Let's look at the why. I'm going to do a quick poll now. So show of hands if you have watched live sports on TV. Great. Show of hands if you watch live sports at a stadium. Awesome. Now I'm going to make myself really vulnerable here, so please help me out, folks. Who's been to a stadium? Show of hands if you've been to a stadium so big, got seats so far away that you could barely see the action. Yep, we've all been there. We love going to sports, right? The emotions, the atmosphere, the crowd, everything is so raw, just so amazing. But lately, I'm starting to love watching sports on TV as well. It might be the America's Cup, the cricket, or the golf. The experiences enabled by broadcasters, various visualizations, really allow you to immerse yourself into sports. And that is why, from the 100 most watched telecasts in 2022, 94 of these were live sports. And that number has been increasing over the past few years. And what's powering this upwards trend? It's real-time data made available to broadcasters, spectators, to drive those immersive experiences. What real-time data enables is strategic to the core of a lot of businesses out there. Let's dive into the sporting industry, for example. As fans, we engage with sports while watching it on TV, for example, or it could be a mobile device. It could be anything with a screen. Sometimes there is no screen. You could be looking at virtual leagues, playing against your friends or your colleagues' virtual leagues. These experiences are critical to drive fan engagement with the sport, with the event, and with each other. With real-time data, statistics, and numbers, help you to choose the right players for your virtual leagues and also enjoy and understand the game at a deeper level. With the accelerated uptake of sports on TV, broadcasters are also looking at doing more with their coverage of sports. It might be the America's Cup, for example, showing you a visualization of the boat speed versus the wind speed or the distance between the boats. Or it could be the last 6 hit in cricket, the angle at which was hit and the distance the ball traveled. Real-time data is the currency of the future, and broadcasters are super excited about its potential in lifting end-user experiences. And finally, real-time data can be materialized at the venue itself. A lot of venues are actually becoming smarter with what they do with real-time data. Applications such as finding your car park at a venue, finding your seats at the venue, ordering food from your seats, or also allowing for fan and player interactions are just some examples of what venues are now doing with real-time data. And just like the sporting industry, here are some other industries which have truly leveraged real-time data to create value. Financial real-time data is everywhere. We all generate it. We all consume it. And that's why traditional financial organizations are also moving to architectures to allow them to leverage real-time data. Logistics is another industry vertical, which has truly leveraged real-time data to create value. I love seeing notifications on when my Nintendo games are about to arrive. Sorry, I mean my kids' Nintendo games, not mine. Yeah. I have peace of mind which I didn't have a decade ago. Questions like, where is my item? When will it be shipped? When will it arrive? Will I be home when it arrives? Those questions are no longer a mystery thanks to real-time data and tracking. And finally, any workload, application, or vertical which requires end-user interaction could benefit from real-time data. As you saw with several examples earlier, real-time data has the potential of really lifting the end-user experience, allowing your end users to make decisions fast with accurate, up-to-date, and reliable information. So as we start our journey towards real-time architectures, I often recommend starting somewhere simple. And this is where Virtualize started their journey as well. A request response architecture is the simplest start to your real-time journey. It allows the end user to make a request and get a response in real time. We all understand the limitations of this architecture as we start to scale. And that's why we often see an evolution towards a microservices architecture. With a microservices architecture, we have remediated some issues around scale, but we haven't remediated the issue around handling real-time data at scale. The end user still is responsible to have intimate knowledge and understand when to make that initial request. So questions like, when should I make the request? How often should I make the request? If I make the request too often, will I be wasting computational cycles? What if I don't make the request often enough? Will I be losing some key information? All those questions remain unanswered. And that's why we see an evolution further towards an asynchronous point-to-point architecture. So in this architecture, we're starting to create alternative channels of communication back to the end user. In this architecture, when a user requests for some information, they get an acknowledgement back or a promise that that information will be available to them sometime in the future. The very near future, we hope, with good system design, but future nonetheless. One of the key benefits on this architecture compared to request response microservices architecture is that the end user doesn't need to have any knowledge of when to make that initial request or when data is available. When data is available, it will get pushed to the end user in real time. And this is super beneficial for our sporting use case. When statistics and numbers are available, it will get pushed to the broadcaster or to the commentator or to us, the spectator, in real time. One of the small drawbacks of this architecture is that a lot of logic starts to live inside your compute layer to understand where to route events and streams. And we often see an evolution further to an event bus architecture. In this architecture, we have introduced a construct which allows you to route events and streams using native filtering capabilities. So as you see an evolution of these architectures, you come to realize that to handle real-time data at scale, you need to move away from request-response architectures. So let's look at a theoretical example of what this might look like. On the left, we have producers and consumers. As producers produce events, you might send them to an integration layer. Over here, you can decide to use one, two, or a collection of AWS services as per your needs. Or you can ingest streams directly using our streaming technologies, for example. Once the event is in there, you can choose to process it using your compute layer. After you process that event, you can send the result back through the end user through the integration services. Alternatively, you can also choose to store the result or the state into a data store. The data store is now responsible using native capabilities to send a notification or a response back to the end user via the same mechanisms. So this is where the journey started for Virtuali, for their cricketing platform called Hyperlayer. For each venue they processed events, they required some key pieces of infrastructure to be present there. Behind this infrastructure, there were 4 key pieces of application. An application to process player tracking information, an application to process ball tracking information, a low-profile computer called a Next User Compute Device, or a NUC, and finally, an application to send the resulting insights back to the broadcasters. So as the cameras process feeds around the venue, they would get processed by these applications and get pushed to a relational database which would reside on this NUC. Operators, which would reside in media vans at the venue itself, would request this information using a request response pattern, create insights from it, and push it to the broadcasters. So this is where Virtuali came to the realization that to process data at scale, real-time data at scale, something had to change. As you saw, the current setup was hardware heavy. They required 250 kilograms of kit at each venue to process events there. Also, they needed highly skilled operators to be present at the venue itself to process events from the relational database and to create insights from it. They did this using highly specialized applications. These applications had a lot of business logic built into them. So any new insights required a redeployment of these applications. The operators also only had line of sight at the venue itself, the current game at the venue itself. They had no line of sight at other games happening at other venues, for example. And neither did they have line of sight of historic data. And because all of this was hinging off a relational database, latency at scale was a key concern. Latency of not only events dropping into the relational database, but for end-to-end insights being made available for end users to consume. We all understand that for sporting insights to be enjoyable, it's better if they are augmented with external data or heterogeneous data. For example, what was the weather like when Mitchell Stark bowled that super fast delivery at 160.4 kilometers per hour? As you saw, the setup currently could only ingest events for ball tracking and player tracking, but no other external events could be ingested. And finally, as data for the event was captured, it was retained for a little while on the relational database and then discarded. The database was scrubbed to prepare for the next game. This data was critical. Not only did it have rich insights, but it also had key details that could be made available downstream to other consumers, either in its raw or curated format. Downstream consumers like international sporting bodies or national sporting teams, or even coaches, for example. And we also wanted to move Virtual closer to a modern data strategy. So with that, I'm going to pass it on to John Rendell, who will take you through their journey.
Kia ora everybody. It's wonderful to be here today, telling you about our all-new hyperlayer platform and the transformation we've taken developing it. We're just a small New Zealand-based company, but work around the globe with broadcasters and sports leagues to help them engage viewers with cutting-edge storytelling tools. In 1990, our founder, Sir Ian Taylor, started the business on the premise that digital data would be the currency of the future, and that we would be the ones to turn that data into pictures that people could understand. Little did he know at the time just how far that vision would carry. Not only was it done on the basis of turning digital data into pictures that people could understand, it was also devised on the basis that we would be the ones to deliver those pictures to people, how they want them, where they want them, when they want them. When Ian founded the business, there was only one screen. It was called a TV. So we started focusing on sports that were hard to follow in a broadcast. First, there was the America's Cup in '92, golf in '97, motorsport in 2000, cricket in 2005, and most recently, baseball in 2019. Even back in '92, for data to be of any value, it needed to be complete, timely, and accurate. This has been the basis of all our work to date. We're just a small team, only 14 developers, and only 2 of which are working full stack, 12 technical artists, 1 systems manager, and a dozen ops professionals. Due to the nature of the work we do, our requirement for on-premise hardware is significant. This includes broadcast-ready PC hardware, file servers, and lots of fast network storage. This is where the cloud comes in. As a company, our strategy to maintain market dominance now relies heavily on its uptake. When thinking about modernization, our cricket product immediately came to mind. More specifically in this case, moving from an SQL database running on a Nook PC to a fully serverless, event-driven architecture in the cloud. The biggest challenge and frustration whilst on this journey was knowing what we needed, but not knowing how to build it. We started researching existing event sourcing options, but none of them really did what we wanted, mainly because they all required managed infrastructure, and we wanted everything to be serverless. From the beginning, we knew we had a challenge on our hands, this being the desire to build something we really didn't have the knowledge or resources to do. This is where we turn to AWS to help us architect and develop an MVP solution. One of the key challenges we identified along the way was our strong desire to build a system we could continue to extend and manage without the need of dramatically increasing the size of our team. And I'm thrilled to say we have achieved this. Naturally, a critical part of the architecture was building a system to be highly scalable, resilient, and secure. Scalable, to allow us to cover an infinite number of events. Resilient, because sports events don't stop for outages. And secure, because our relationships rely on customers knowing their data is safe. Lastly, we wanted to design a system that enabled us and our customers to more easily access the data. The key part being developing a system that had more granular access controls around the who, the how, and the when. Here's a snapshot of our current architecture as touched on earlier by Ruskin. As you can see, it's pretty basic. Versus hyperlayer, a fresh approach focused on taking advantage of the cloud. Now all our data, tracking and video are sent directly to AWS. Telemetry, including ball tracking, bat tracking, and player tracking, are ingested by Kinesis and processed at scale using Kinesis data analytics before being stored or on-sent for live use. Likewise, video that was once dumped after every game of cricket we covered is now sent to Kinesis video streams for further processing and deep analysis before being stored for later use. It is important to note that not all our data was moved to an event-driven architecture. Some data, including static player information, was simply moved to a NoSQL database. Within our downstream visualization apps, our operators can now subscribe to event streams with automated insights, helping to streamline their operation and create new and interesting stories. Perhaps the biggest breakthrough as we transition to the cloud is our ability to store data at almost infinite scale using S3. Better still, this allows us to continue exploring the value of the data we have well into the future. Finally, Hyperlayer opens the door to use of our data by third parties, and we're really looking forward to seeing what they're going to do. Now let's take a look at how our data is used by us in a broadcast. Here we see the incredible consistency in the bowling patterns of Nathan Lyon. I sure wouldn't want to be up against him in a game of backyard cricket. And here we see our hit tracking data with launch angle and speed, and in how it is used to tell the story of this tremendous six by South African cricketer Tumba Bavumba. And here we see the tactics of British cricketer Ollie Robinson as he pressures Warner to make the play. His final delivery is a little more on the full and forces Warner to make the play. And in this one, we see all the deliveries of Pat Cummins in the session. The white balls are highlighted in white are wicket balls. And here, our player tracking system. This is used throughout the broadcast to show the ever-changing field configuration, which is highly dependent on the batter-bowler combination. And last but not least, our all-new bat tracking system. Here we see Alzari Joseph hitting the ball right on the sweet spot and achieving a beautiful shot for six. Up next in the development of Hyperlayer is an exciting new phase where we start to explore all the incredible data we have. The new Stat Search tool will enable us to interrogate the data in ways that have not been possible before. Want to find out who hit the most fours and sixes in the Big Bash League? Or even look at the bowling patterns that correlate to that success? This is what Hyperlayer Stat Search will start to enable. Over the last 15 years, we've covered hundreds of international and domestic league cricket matches. Just imagine the types of insights we're going to start finding. Take things one step further and integrate this data with our virtual eye graphics engine, and you get this. See that six you queried earlier? Or want to see every six by that batsman across the season? Hyperlayer Stat Search will enable this and much, much more. This truly is digital data, how you want it, where you want it, when you want it. Now let's take a look at some of the takeaways to expect when moving your business to an event-driven or streaming architecture. The first step to realization is making a conscious decision to use an event-driven or streaming architecture. It is important this decision is made for the right reasons, adding value to your business rather than merely an engineering venture. One thing that made our journey easier was that we understood our domain. It was cricket. We understood that events, such as a ball being bowled, are not as important as the resulting insights. We also understood that streaming data, such as ball tracking, is not as important as the resulting outcome, for example, a wicket. So make sure you look at your events through a domain-driven lens to help you stay at the macro level. Real-time data, once captured, is key. Even if that data is not used right away, it may well contain valuable insights that can be derived in the future. Storing your data in its raw and curated form allows you to maximize on your high-velocity, event-driven architectures well into the future. Ruskin touched on latency earlier in the session. The key takeaway here is that earlier in the process, we focused a lot on micro-level latency. For example, how quickly an event can be processed. It was, however, quickly understood that it was not the latency of individual events, but the latency and insight can be delivered. So when you design your systems, how long does it take to realize value from your events and streams is the question. Now let's take a look at some of the takeaways for our company. Hyperlayer is designed for scale, with the ability to dynamically adapt to ever-changing demand without compromising on performance or reliability. Better still, it allows us to scale our business without scaling our physical footprint. It has been our goal since the beginning of this project to use technology to solve the challenge of scale rather than physically increasing our footprint. And I'm thrilled to say we've achieved this. Probably the biggest advancement we have made with Hyperlayer is end-to-end data modernization. From a total infrastructure overhaul to use of the latest data management systems, including going fully serverless and moving to a data lake with ingestion, storage, and processing layers. This gives us infinite scale and allows us to keep our data stored in its raw form forever. Moving forward, this allows us to explore new opportunities with machine learning and data-driven insights, areas we are really looking forward to doing more in. We're just dipping our toes in this metaphorical data lake, but our eyes are wide open to the market opportunity it represents for our business. Global sports media rights are estimated to be valued at $54 billion, and by 2025 are set to peak at $60 billion. So if we can tap into just 0.1% of that market with Hyperlayer, it is a $60 million opportunity for our business. Thank you very much for attending our session today. Now I'll pass it back to Ruskin, who will tell you about how AWS Skill Builder can help you on your journey.
Great, thanks, John. So as you start your journey towards real-time architectures, make sure you check out Skill Builder. You can schedule on-demand or in-classroom training options to accelerate your pathway to innovation. And I firmly believe that as far as knowledge is concerned, there's no better time to start than now. So with that, I thank you again for attending the session. Please complete the survey in your app. Add us on LinkedIn. We would love to keep in touch. John and I will be over here at the end of the session and also head to the AWS booth. Come talk to us about your real-time journey. Enjoy the rest of the summit.